Okay. So again, there are no real announcements today, other than we're just going to kind of keep plugging and chugging. We're moving into section 1.5. We can anticipate exam two during week 8. So we got a couple. It's out. It's a couple of weeks out. Um, yeah, no real announcements. And so we need to get through about 15 slides today, which is it's not going to take that long. And then the remaining time we can use it to either you know either work homework questions. You can ask any question from the homework that you like, or you can ask questions from Alex. All right, but let's save that until let's finish. Let's hit the mark that we need to hit, and then we'll call it that in. So continuing chapter one. Oh, hang on. Let's go like this, like this. Close it out. All right. So yeah, continuing with chapter one, we're moving into section 1.5, transformation of functions. So the goal here is we're going to take the basic functions that we introduced last time, where we had this library of functions, and we're going to start to introduce transformations and manipulations on them. So we're just kind of developing some graphing techniques that we kind of use in college algebra, and I mean they work beyond college algebra as well. Okay. So if a new function is formed by performing certain operations on a given function f, then the graph of the new function is called a transformation of the graph of f. Right. So if we let f of x be absolute value of x, and then g of x is going to be the absolute value of x plus 2, and h of x is going to be the absolute value of x minus 3, then we're actually sketch the graph of these functions on the same coordinate plane and describe how the graphs of g and h relate to the graph of f. Right? So to introduce, we're going to make a table. So choose some x values, find the corresponding y's, right? So we chose these x values, right, from -5 to 5. And then we plug those x values into the basic function of absolute value of x. And then we also plug them into this transform function, absolute value of x plus 2. All right, so absolute value of -5 is 5. Then if we add 2 to that, we get 7. So on and so on and so on. All right. So what kind of change can we notice going from the blue being the original to the red, which is new? What kind of change did we do? It shifted up by a factor of 2, right? So the first transformation that we have, if we add a positive number on the outside of our basic function, it shifted it up by that many units, right? So if we add a positive on the outside of our basic function and it shifts it up, what do you think happens if we subtract a positive on the outside? What can you anticipate happening? It should go down, right? So if we subtract a positive, if we subtract a positive on the outside of our basic function, we're anticipating it going down. Right? So we still have our values of x, the corresponding y's, or absolute value of those x values, and then absolute value of x minus 3, right? Okay. And we can see from the graph after we plot those points, it did indeed take the original function and shift it down by a factor of 3 units. So now the vertex went from being at the origin to being at negative 3. Okay. So this kind of recaps these first two transformations that we just introduced. This notion of transforming graphs is not a hard topic to a difficult topic to comprehend, but it can be information overload. It's going to be a lot of information in a little bit amount of time. But maybe because of the way we're doing it, as far as like meeting 4 times in a week for a short period of time, maybe that'll help it to sink in a little bit better. So if C is positive, then the graph of f plus c, if we add a positive on the outside, it's going to shift the original function c units up. And if we subtract a positive on the outside, it's going to shift the original function c units down. Okay? So then if we take a look at this one, here our basic function is x squared. What kind of shape is f of x equal to x squared going to give us? Right. So we have our basic function here. Now notice this minus 2, we subtracted a positive inside our basic function. And here we added a positive inside our basic function. So if outside manipulations cause vertical changes, what can you anticipate inside manipulations to cause? So inside manipulations are going to cause horizontal changes, right? So, okay, just if you had to guess, if we subtract 2 on the inside, which way do you think it moves? Do you think it moves to the left by 2 or does it move to the right by 2? If you had to guess. Right. So notice that the negative 2 was on the inside and negative x does go left. Let's see what happens though with this negative 2. Right? So here we subtracted a positive 2 on the inside, right? And we had something like this going on, right? And then when we added a 3 on the inside, we got these kind of results. So let's see, when we subtracted the 2 on the inside, did it follow our intuition or was it the reverse of our intuition, right? So the blue is the original. Notice that when we subtracted a positive on the inside, instead of going left, it actually went right by a factor of 2. So the moral of the story is, Melange, okay. Give me just a moment. There he is. All right, keep the party going. Hop back over here. So the moral of the story, when doing inside manipulations, typically it's the reverse. Is the reverse of our intuition. We anticipated subtracting a positive on the inside to move it left. Hang on. Okay. So we anticipated subtracting a positive on the inside to move it left, but it actually moved it to the right by a factor of 2. Notice adding a positive on the inside, we would think that it would go in the positive direction, but actually it goes to the left by a factor of 3. So inside manipulations typically elicit a horizontal change, and it has the reverse. It typically behaves in the reverse of our intuition, right? Okay. So we have our basic function x squared, and we subtracted 2 on the inside. And so it says the x-intercept of this is 2, right? The vertex here originally was at the origin, but now the vertex is at positive 2. So for each point x comma y on the graph of f, there will be a corresponding point x plus 2 comma y on the graph of g. Shifted 2 units to the right, right? Okay. And this is a similar discussion, but this is going to be 3 units to the left. Okay? Inside is typically the reverse of our intuition. Okay. So if we let c be positive, then the graph of y equals f of x minus c, right? Oh, I totally forgot about it. Oh, this is a different guy. It's Brown. Mr. Brown. Okay. Whew. And let me restart this again. So again, inside manipulations are typically the reverse of our intuition, and they go side to side. They elicit side to side changes. Okay, I think we talked about those two. So again, let c be positive. Then the graph of f of x minus c should be is the this is going to be the graph of the original function shifted c units to the right because of that minus c, right? And then this plus c is the original function shifted c units to the left. Okay. Okay. So for the rest of class, we can use this time to kind of be working on Alex. And you can ask questions from any of these sources like Alex or the homework or anything on Pearson. But now is a good time. If you have questions, now is a good time to ask them. Let me do it like this. Like this. Okay. So I am just here to kind of to answer questions.
You unlock the room or no?
I think it's unlocked.
Oh, it is?
Yeah. He didn't make an in from before. Yeah. You can actually access any assignment that's on Pearson, right? Any old assignment, it's all there. If it's late, the highest you can get is a 90 on any question submitted late. But yeah, anything that's on Pearson, you can work on it and boost your score. If it's late, then it's like a 10% late penalty. Otherwise, if it's on time, it's just there, waiting for you to kind of complete it. Let me go ahead and load this one as well. Okay, guys. So I'm nearby. If you have questions, just feel free to unmute yourself. Alex, okay. Yes, it's okay. Yeah. Uh, so
Yep.
Alex will do on like a weekly basis, right? So as long as you're like, let's just go ahead and try to have them do our best to have them done by Saturday by midnight. My colleague is just going to be sending me a weekly report, so she's just check at the same time every week. But as long as you're consistent, like consistently get them in before Saturday by midnight, then it'll actually work itself out. Everybody should be doing a minimum of 25 topics per week. And then if you're on the prep for intermediate algebra, we need to be doing 35 topics per week. And if we're doing prep for basic math, we need to be doing about 50 topics per week. Um, and the goal is that everybody by the end of the semester is at or above prep for college algebra by the end of the week. I mean, by the end of the semester. Okay. So again, I'm just here if you wanted to ask questions on Alex or questions on Pearson, or anything like that.
If,
Go ahead.
if we don't have any questions, are we free to leave?
No, we need to just kind of be working. Yeah, we just need to honor the time. It's not that long actually. It's like a little over 10 minutes. You see what I'm saying? So just chill for like 10 minutes. Be working on something. Like we have enough to do. So now is a good time to kind of be working. But yeah, otherwise just chill. In like 10 minutes and then you're free. Nobody's gonna like mess with you then. So is the work on Pearson coming okay for everybody? So like what was the deal with Pearson? The main thing is that we're gaining full access to Pearson. If we're not able, I think we have a workaround, to kind of accommodate people and buy some time essentially. I probably will around midterms for the grades. But essentially, what's on like Pearson is like 90% of our grade, right? So whatever you see on Pearson, I'm just gonna scale it so that's gonna total up to 90% of the grade, and the other 10% is gonna come from Alex, right? That's the gist of it. And then I think exams. I think each exam should be like 20% of our grade. However it is on the syllabus, that's what I plan on doing. So I'm not. I think I did 20% for exams, and then however it is on the syllabus, that's how I'm gonna do the scale. I mean, I can. Yeah, I could put the grades in Blackboard. I probably do it around midterms though, after exam two. Okay. All right, let me see. And now feel free to unmute yourself. I'm gonna step away, but I'm like around the corner. Just unmute yourself to get my attention. Let me see. Hey Siri, set a timer for 10 minutes.
Your timer is set for 10 minutes.
And also, as you make your way through the assignments in Pearson, if you need help with any of those questions, be sure to make use of the Ask My Instructor. I I do make dedicated YouTube videos walking students through those questions. And also be sure to be subscribed to my YouTube channel with your notifications turned on. So as I make these responses, you don't even have to watch the videos, just so you can be aware. Like, oh wait a minute, I think you did a video on that. Let me go look. All right, and so that way we can all try to do our best to be on the same page. Okay. Ho ho ho.